guys, back here. I just wanted to show you one more thing. Um, so I am actually doing the next thing from where I left off, part two of the procedure directions, and doing A. Okay, so I'm back. I'm back in ChemSketch. I've got butane drawn and 3D optimized. I will go ahead and open back up 3D viewer. And then, okay, go back into ChemSketch. I actually heard from some folks today that it sounds like a lot of folks are having this sort of slowness problem in 3D Viewer. That's happening to a lot of people. That it wasn't that way in the past. I don't know if it's some sort of glitch with the software. You can get through the assignment. It's just a little bit annoying compared to how it used to be. Anyway, okay, so copy to 3D. All right. It looks like it's in staggered anti right now, but let's go ahead and do some optimizations just to make sure we're in good shape. Maybe wait the 10 minutes, a little bit. Let's do another one. A little bit, not much. Okay. All right. So now we're going to do bond angles, and a couple things about bond angles. I wanted to give a warning, and I see that I have actually added the warning to the procedure instructions here, but it's worth telling you, and also how to get out of some problems. Basically, in this assignment, you're dealing with two different possible hybridizations. Okay, so one possible hybridization is sp3. The other possible hybridization is sp2. You by now are well aware of what the bond angles ought to be for an sp3 atom. Okay, they should be 109.5. And then for an sp2 atom, they ought to be 120 degrees. Okay. In looking at some of the bond angles of butane, we are looking for subtle variations, and then we're going to try to explain those subtle variations from, in the case of butane, from 109.5. It might be, when we get down a little bit farther in the instructions, it might be a very subtle variations in 120 because it's an sp2 carbon. Okay. Point being is, if you end up checking your bond angle and you get 250 or 200 or something like that, that's not a subtle variation. Something's wrong and you need to redo it. What I have found is that a lot of the time it seems to be a matter of, when you do these bond angles, bond angle is always three atoms, right? Three contiguous atoms. And so for me, it seems to be you can fix a crazy bond angle like 200 or something like that by reversing the order. In any case, let's try one real quick, and we'll see what we're talking about. Okay, so we want to go up to the bond angle tool, which is right there. We click that guy. Now that should automatically switch to the select atom, and it does after 10 minutes. All right, and then we'll come in here. The first one it wants us to do is H1C1, H1. Well, H1 is going to be on the C1 carbon. So there's C1, C2, C3, C4. Or you could have just as well numbered it the other way, 1, 2, 3, 4. And so H1 is going to be H1, C1, H1 are these atoms here, H1, C1, H1. Okay, so let's go ahead and, when we see the numbers come up, click green. Come on, green. There we go. Click green. Time. Green. And then our angle should pop up. Let's see what we get. 108.8. That's fine. So you can put that into your worksheet in the appropriate place. Just out of curiosity, let's see what would happen if we did it in the reverse order. We start on this atom. Oops. Gotta re-pick this. Oh, geez. Now everybody's cranky. Settle down. Okay. That guy. That guy. Okay. All right. Green. Green. And green. Did I get it? No, maybe I didn't get that one. Green. Oh, look at that. 251 degrees. Just by reversing the order. Makes zero sense, no explanation, but you should recognize that's crazy and redo it, probably changing the order of the atoms you click. Let's do another one real quick. Another detail I wanted to make is, let's see, I can move that guy. Oh, I need to go to 3D rotate. Okay. So that does. Wait the time. Okay. All right. When you want to do in a bond angle, I think it's important that you try to make sure that you can clearly see the atoms. Say I wanted to get the bond angle of C1, C2, C3. Oh, that is that's the next one you're supposed to do. So I mean, it may work, but you see how this one is kind of obscured? I think it's better. Actually, I'm not even going to do it with it obscured. I think it's better, twist the thing using 3D rotate so that you can clearly see it. Okay. So if we want to do C1, C2, C3, let's twist that guy like that. Come on. All right, that's probably good. So now let's try it. Oh, we're interesting. Okay, angle. Wait for it to switch over here. There we go. C1. C2. C3. What hybridization is this carbon? So what do we expect? We expect 109.5. It's a subtle variation of 109.5. You're asked to explain that later on. Everything's peachy. All right. Yeah. And so, like, the next one is H2C2H2. So you would go to the second carbon, either that one or that one, depending on how you want to do it. Let's go to that one. And then H2s are going to be these guys. So H2 to C2 to H2. Okay. All right, guys, that should be enough to get you well on your way. I maybe have said too much here, but that's okay. As long as you learn about these concepts, that's our ultimate goal. Okay, guys, have fun. Sorry the program is so wanky. I don't know why it is, but yeah, you can get her done either way. Okay, take care, guys. Bye-bye.